If you're interested in learning about data center networking, then the latest Juniper Associate certification might be right for you. I'm JB, this is Cyber Insight, and today we're going to be doing a practice test walkthrough of the Juniper JNCIA-DC. You know how this normally goes. I'm going to hop over into my browser. We're going to get into that stuff. But first, since you're here, appreciate it if you smash that like button. And even more importantly, go ahead and hit that subscribe button if you haven't done that yet. That way you don't miss out when I drop new content. And it's a great way to show me that you appreciate the channel. All right, let's get into this. We're going to do a little bit of background first, because if you've been following me for a bit, you know how much I love Juniper technologies. And I think over the past couple of years, I've done, 6 of their associate certs. So mine were about to expire. And instead of going and taking one of the ones that I've already done, luckily Juniper lets you, if you pass one associate cert, it re-ups the rest of them. So they put out a new associate cert that I hadn't taken yet, this one dealing with data center networking, called the JNCIA-DC, and I figured why not go after that, and that way I'll have all 7. So I do want to give you just like a quick, maybe like 30-second breakdown of the different topics that are in here, just so, you know, if it aligns with stuff that you want to learn about, then it might make sense for you to dig into this a little bit more. So right off the top, a few different things are going to be hopping into data center architectures, and that's going to be talking about kind of the traditional things that we're familiar with when it comes to the core distribution and access type of architecture. Kind of the newer way that folks are looking at doing things with kind of IP fabric architecture, dealing with spine and leafs, talking about overlay, underlay networks, VXLAN, EVPN with BGP, stuff like that. And if you aren't familiar with those, and maybe that is why this might be something that makes sense for you to dig into a little bit. Some other things that it covers is going to be talking about layer 2 configurations, specifically dealing with switching within a data center. So that's going to be looking at things like port aggregations, different ways to secure the traffic, different ways that MAC addresses are learned, broadcasting, VLANs, all that type of stuff. Then it dives a little bit more into different types of routing that's used within a data center, and then specifically does a pretty good dive into both BGP and OSPF, since those are routing protocols that are mainly used for underlay networks. I think the last thing that it kind of talks about and covers is high availability. So again, kind of going back to the different types of interfaces, and specifically layer 2 interfaces, and different ways that we can go about doing stuff, and making things be a little bit more redundant and available. So looking at things like link aggregation, so things using like LACP and things like that, graceful restarts of services, bidirectional forward detection, virtual chassis, where you're kind of combining 2 different physical devices together into one virtual thing. So yeah, a lot of great stuff here, some stuff that you might have some background with, some stuff that you might not. But if you're a network engineer, these are all great things to have an understanding of. Now, as I had mentioned before, I've done, 6 of these associate certs at this point. So I'm not going to go too much into Juniper and the way that they have, you know, all their different free training, which they do have for all the associate certs, free training, free practice tests, and also at this point they have a voucher assessment test. You can kind of see that down here at the bottom. If you pass that, then they give you 75% off the cost of the associate exam. If you're interested in any of that information, specifically about all the other associate certs, I'm going to point you over here to this playlist I have. I put the link in the video description. I have practice tests, review videos, all sorts of good stuff for all of them. So you can definitely go and dive into that. Let's see, from here, what we want to do, this is the actual free training itself. You'll see I'm about halfway through this, but for the most part, I'm familiar with a lot of these topics, so it's not like I'm necessarily learning them for the first time. The other things that are kind of important and what we're going to be focusing on today is that they have a free certification practice exam. So once you get a Juniper account, you log into the Open Learning portal, you sign up for this course, and you have the ability to go and take this practice exam. This is different than the voucher assessment test, but a lot of times the questions are pretty much very similar. So once you feel good enough with this, I'd say good enough to go and take that voucher assessment test. I think you get 3 tries at that. And I think you need to get a 70% to be able to get the 75% off voucher for the exam. So pretty good stuff. So let's go ahead. We'd go and we'd click into that to get the test going. And yeah, what I like to do with these is just kind of go through each question. I'm going to tell you why I'm going to pick what answer I'm going to go with. I think with these Juniper practice exams, they aren't going to tell us the answer until we get to the end. Luckily, it's only 40 questions, so it shouldn't take too long to get through there. And we'll kind of just see how it goes. If you have any questions as we're moving through here, you can go ahead, throw those in the comment section. But yeah, people seem to like these practice test walkthroughs seem to be helpful because it provides a little bit of clarity. And a lot of times the things that I'm thinking are the things that other people are thinking when they're kind of going through the process of elimination when it comes to these types of questions. So let's hop into it and see how it goes. All right. So what are two characteristics of a typical eBGP underlay fabric? So an eBGP fabric does not require an IGP to advertise its loopback IPs. So I'm going to say that is not true. Or it says it does not require IGP to advertise. So I would say that is true. So we'll choose that one because for the underlay, remember I said we could use OSPF or BGP or ISIS, really a whole bunch of different things underneath. And so BGP, for instance, isn't a interior gateway protocol routing protocol. So I would feel pretty good saying that. An eBGP fabric relies on an IGP to advertise it back. So that's the opposite of that. So we're not going to choose that. Each device in an eBGP fabric will be configured in its own unique private IS. I would say that is true. So we're talking about using eBGP here. So since it's external BGP, it should be connecting between separate ASs. So that would seem to make sense. And then each device in an eBGP fabric will be configured to be part of the same private AS. So again, opposite of that. So pretty comfortable with both of those answers. Which statement is correct about a 5-stage IP fabric topology? So this is when we're talking about a spine and leaf topology, although it kind of grows to the point where it needs to have, I forget the name of the terminology, but pretty much like a super spine up above that to connect. So it's at this point, it's 3 levels instead of being 2 levels. So the answers here would be there's a maximum of 5 hops between any end devices. Seems reasonable. They're typically deployed in small to medium data centers. No, so they would be deployed in large data centers where it gets to the point where there's too many connections between the spines and the leaves, and you kind of need to extend that a little bit more. They're commonly referred to as an interconnected data center. There's a maximum of 3 hops between any device. No, so the 3-hop one would be kind of your regular spine and leaf topology. But this one, since it's 5-stage, we're going to go maximum of 5 hops. Which statement is correct about an IP fabric? Load sharing is provided by the routing protocol used. I like that. That seems reasonable. The entire IP fabric is one large broadcast domain. That is absolutely not. So the fabric is going to be kind of like the underlay. So that's going to be used to connect between different sites or locations, or even within an environment. It could just be what's used to allow the overlay, which is going to extend the layer 2 environment over that. So that would not be one large broadcast domain. Loop prevention is provided by the underlying spanning tree protocol. Nope, because we aren't really sending layer 2 traffic on that IP fabric, so that would not be it. Transit traffic is passed through the network based on the original frame's destination MAC address. Again, in that case, transit traffic, if we're using something like VXLAN, once it goes to go through the underlay environment, so kind of connecting the 2 different VTEPs, we're not really using the original frame's destination MAC address. So we'll go load sharing is provided by the routing protocol used. So depending on what you're using there, that's going to determine how it's going to load balance across the links across the IP fabric. So we refer to the exhibit. How many stages are in this IP fabric? So we actually just kind of had a question that looks similar to this. So how I was talking, it was kind of like 3 layers. And that's kind of what we got here. So these would be the leafs connecting directly to the end devices. And these would be the spines. And you see, this would normally be a 3 stage fabric if it was just these switches here and these switches here. So it would go 1, 2, 3 hops, right? But in the case where it grows too much from a spine perspective and you need to go and have like those super spines up there, then at that point we're talking about a stage 5 fabric. So we'll go with that. Which two protocols can you use for a data center underlay network? I actually kind of talked about that when we were doing that high-level breakdown of the exam. So the underlay, we're needing to have some type of routing protocol there. And so the options that we have are going to be eBGP and OSPF. For the overlay, we were talking about using something like VXLAN with EVPN. Referring to the exhibit, which two statements are correct about the IP fabric? So again, we have spine and leaf, but it's a 5-stage fabric, again, not a 3-stage. We have those super spines that I mentioned. Traffic within pod 1 doesn't need to actually go up to the super spine. It's just going to stay down at this level, but traffic going from pod 1 to pod 2 is going to have to go up to those super spines. So this is a 5-stage fabric. Only traffic between pods must traverse the super spine devices, which is what I just said. All traffic must traverse. Nope. So we're going to go with those two. Seems pretty good. Okay. We'll see how many questions I'm going to get into this before I start coughing. Let's see. Referring to the exhibit, what needs to be done to make this a valid IP fabric? So we have our leaf nodes down here, or our leaf switches. We have our spine switches. Each leaf needs to have a connection to each of the spines, which we have. Problem is, in this type of architecture, we don't actually connect the leaves together. So these connections here we're going to want to get rid of. So remove the connections between leaf node. Yes. Add connections between the spine nodes. That would be kind of the same thing that's down here. We don't do that. Add 2 connections between the spine nodes. Absolutely not. Remove one of the redundant links between the leaf and spine node. That would kind of get rid of the whole purpose of the architecture. So we're going to go with the top one. Referring to the exhibit, how many broadcast domains are present in the topology? The good old collision domains and broadcast domains, right? So collision domains is going to be individual physical connections coming off of the switch. If it was a hub, then all of the connections off of there would be a single collision domain. When it comes to switches, each physical interface is going to be its own collision domain. And every VLAN is going to be its own broadcast domain. So looking at this, how many broadcast domains are present in the topology? There's only one VLAN being used, so we're going to say there is one broadcast domain. How does a layer 2 switch populate its bridge table? So this is kind of talking about how a switch is going to go about learning MAC addresses. And normally the way that this works is when the traffic comes in an interface, if there isn't already an entry in the MAC address table, then that's going to get entered with the physical interface that the source MAC address came in on. So let's see what I got here. It stores the source MAC address of frames traversing the network, which I think is what I just said. So we'll click on that initially. It stores a protocol number of frames traversing. Nope. It stores the destination MAC address of frames traversing the network. Nope. It stores both the source and destination. Nope. So the way that works is traffic coming inbound on interface looks to see if it's in the table. If it's not, then it writes it to the table. What happens if a frame with a known destination MAC address enters a switch? The MAC address is added to the bridge table. No. If a frame with a known destination address, no. It's not added. The ingress packet forwarding engine sends the header information to the RE. No. That's going to be if it doesn't know that. Let's see. The egress PFE performs a MAC address lookup and determines the ingress PFE. No, that seems backwards. So it'd be the ingress PFE. So that's going to be the interface that the traffic is coming into. PFE for that inbound is going to perform a MAC address lookup. It's going to determine the egress that's going to be going out. So pretty comfortable with that as an answer. Let's see. Referring to the exhibit, which statement is correct? The GE000 interface has been explicitly assigned to a VLAN name default. Yes. Has been explicitly assigned. The asterisk indicates that the interface is active, which is correct. The GE0012 interface is an access port. I'm going to say no because we see 12 on having multiple VLANs associated with it, so that means it should be a trunk port. The default VLAN is a user-defined VLAN name. Well, the default VLAN is VLAN 1, and we see that it has a default, so that would not be it. So asterisk indicates that the interface is active. I think I'm pretty good with that. Yes, we will go with that. Which two statements are correct about trunk ports? By default, trunk ports can transmit and receive untagged traffic. I don't know that that is a true statement. I feel like in order to do that, you have to set the native VLAN command. Trunk ports typically connect to other switches and routers. I would say that's a good one. By default, trunk ports can transmit and receive VLAN tag traffic. 100%. Trunk ports typically connect to end users and servers. No, that would be an access port. So let's go with those two. That sounds good. Referring to the exhibit, how many collision domains are present in the topology? So we had one, we were looking at broadcast domains. Now we're looking at collision domains. Remember, I said if it was a switch, then all the interfaces would be in the same collision domain. Since, no, did I say switch? I said if it was a hub, they'd all be in the same collision domain. Since this is a switch, each physical interface should be its own collision domain, so we are going to go with 3. What is a VLAN? VLAN, a broadcast domain identified by VLAN ID. I like that. A broadcast domain using only virtual machines. That would be incorrect. Physical machines can be in a VLAN. A local network using only virtual machines. Nope. A multicast domain identified by a VLAN ID. No. So we're going to go broadcast domain identified by a VLAN ID. All right, I'm going to take a sip of water real quick. Any questions? You can throw those in the comment section. Okay. What two statements are true with regards to MACsec? It does not provide authentication for Ethernet traffic between 2 network nodes. I believe it does provide authentication. It provides authentication and it provides encryption. It provides authentication for Ethernet traffic between 2 network nodes. We'll go with that. It does not provide encryption for, nope. So we're going to go with it provides authentication and encryption for Ethernet traffic between 2 network nodes. And this is at the layer 2 level, where IPsec is at the layer 3 level. What is the default Junos behavior for access ports? Allow only tag traffic. I don't think so. I think it could be configured to allow tag traffic, but I think it's going to allow untagged traffic and tag the traffic when it comes in. Allow a maximum of 80% untagged traffic? No. Allow both tagged and untagged traffic. We're talking default, not what it's capable. So if it's capable of doing both, but I think the default behavior is to only allow untagged traffic, and then it's going to tag it with the VLAN ID that you assign to the interface. Or it could be the default VLAN if you don't assign it. What is the default route preference for a static route on a Junos device? Oh man, I love route preference questions, especially when you don't study them too much too often. So directly connected routes, I believe, are like 1. And then the next one down kind of in the preference list would be static routes, and I think that's 5. And then you end up getting into a whole bunch of stuff with BGP, eBGP versus iBGP, OSPF. God forbid if you're using RIP or something else like that in there. Under which Junos hierarchy is a static route configured? So routing instances, system, or protocols. Pretty sure it's one of the ones with routing in it. I think it's under routing options. Yeah, so I think if you were adding a static route, it'd be like edit or routing. It would be edit and then set routing options, static something or other. Yeah, we'll go routing options. You've configured a load balancing policy. Which statement is correct about applying the policy? The policy is applied as an import policy under the routing protocols hierarchy. So I think when we're talking about load balancing, we're looking at it from the perspective of it going outbound. So I think it's going to be an export policy. So I'm probably going to skip these two. And these last two here, the policy is applied as an export policy under the routing protocols hierarchy. Or the policy is applied as an export policy under the routing options forwarding table. I believe that since you could be doing it across multiple routes from different routing protocols, it's going to be under the routing options forwarding table. What is an aggregate route? It's a combination of multiple routes together. Let's see. A mechanism that allows multiple routes to be summarized into a single route. I like that. A static route with only one contributing route? No. A group of IP addresses to which the router will not forward traffic? Absolutely not. Often called the route of last resort, or a gateway route, perhaps, but no. We're going to go mechanism that allows multiple routes to be summarized into a single route. Which two prefixes are contributing routes to a 10.20.0.18 aggregate route? Okay, this is fantastic. So a lot of people get used to just going the subnetting with the /24, you know, and longer routes, or smaller, depending upon which way you want to look at that. So with this being a /18, we're going to look at a few things here. So we're talking about multiple routes that would fit into here. That would mean anything with a lower number than this cannot fit into that. So we can just cross that /16 off as an option. Then we would want to look at how do we figure out where the boundaries are for a /18. We know that the /16 starts on the 0. If we go to /17, that pretty much is going to take this and cut it in half. So it would be starting on 0, and then the next one would be starting on 128. When we go and we look at a /18, in essence, we're taking that, what we broke up into 0 through 127 and 128 through 255. We're going to take that and cut those again in half. So really it would be 0 up to 63 and 64 up to 127 and 128 up to 191 and then 192 up to 255. So those would kind of be the 4 different groups that would be within a /18. But since we're starting on the 0 here, we know that it has to be the first group. So it has to be something 0 through 63, right? So 100 is higher than that, so we can cross that off. So that's going to leave us with this /24 here that starts on the 0, and this dot 60, which is a /23. So both of those would fit within this route here. If you are uncomfortable with subnetting and supernetting, and you saw I did that all in my head on the fly, I have multiple videos going over subnetting and supernetting. I have a whole playlist for it and some kind of handy infographics to help you kind of visualize where those network boundaries are. Go check that out for sure. And don't believe people when they say that people never subnet in their head. They most definitely do. Although if you need to check your work with a subnetting calculator, it's always a good thing to do, so that way you make sure you're right. What does the qualified next hop feature do when configuring a static route? So instructs the device to look up the static route's next hop that is not directly connected. I don't think that's it. It specifies the IP address of the directly connected device. No, that's not it. It allows you to specify independent route preference value for an additional next hop. I think that might be it. Instructs the device to verify the next hop is reachable before activating the route. I don't think that's it. So we're talking about qualified next hop being a route preference that you can set for the next hop. I think that's it. We're going to go with that. I'm not 100% sure, but kind of comfortable with it. We'll see. What statement is true about load balancing? Load balancing is only supported after applying an advanced license. Load balance is only supported by dynamic routing protocols. No, that's not it. You can definitely do load balancing in some other ways. I don't know about advanced license. Load balancing on Juniper devices is process per packet. I don't think so. That would lead to some asymmetric stuff. Load balancing on Juniper devices is process per flow. I like that. So that would be flow one IP address to another IP address. Yeah, let's go with that. That sounds good. You are configuring OSPF in your network as shown in the exhibit here. R1 has been configured with an interface metrics, which is what we're going to look at here. All other links in the network are using the default interface metrics. In this scenario, which OSPF interface on R1 will be preferred when routing traffic between R1 and R5? So kind of need to know a few things with this. First is when it comes to OSPF, they're going to add up the value of each of the links. And the lower the number, the more preferred that path is going to be. So looking at this, coming from this router here, GE000, has a value of 10. 1 has the default value. 2 has a value of 100. And 3 has a value of 150. So we know that we're talking about we want whatever the lowest path is. And the rest of these, that one, that one, that one, are all the default. But we don't necessarily know what that is just yet. Just using logic to get rid of things, we pretty much can get rid of 2 and 3, because since these paths have the same value, we know that this 0, which is has a value of 10, is lower than 2 and 3. So that leaves us with 0 and 1. Now, when it comes to what the default value is, you're going to have to kind of know that. And it's kind of funky with OSPF. It's like it's never been updated in a really, really long time. Pretty much, I think anything that is 100 megs or faster has a value of 1. So the default value here is going to be this GE001. It's going to have a value of 1. And then all these other links here are going to have a value of 1. So the whole path here would be going out GE001 would be 1 plus 1 equals 2. Versus this interface, a GE000, would be 10 plus 1 equals 11. So 2 is a lower number than 11. So we're going to go with GE001. Okay. What are 2 common reasons for BGP routes to be in a hidden state? Choose 2. Routes are being rejected by policy. I like that. We'll put that one initially. The BGP neighbor is in a different autonomous system. Absolutely not. That's actually kind of the point of BGP, is that we're routing between different autonomous systems, especially for eBGP. The next hop is unresolvable, like that. Routes are being filtered from the INET2 routing table. Now let's go. Routes are being rejected by policy. Next hop is unresolvable. Sounds good to me. And this is just one of those questions. What protocol and port does BGP use for control plane communication? You can just kind of memorize this over time after you've done it enough. It's TCP 179. And let me just make sure that I actually did do that. Yes, I didn't get switched up with that 7 and the 5. Which two statements are correct about BGP? Let's see. eBGP sessions are typically established between router loopback interfaces. Seems reasonable. iBGP sessions are typically established between physical router interfaces. I'm going to say no. Normally, BGP in general, you're going to be using router loopback interfaces. iBGP peers do not advertise routes learned from iBGP peers to other iBGP peers. I like that. I like that. And eBGP uses the AS path to avoid loops. Ooh, I feel, iBGP peers do not advertise routes learned from iBGP peers to other iBGP peers. I feel like that is correct, and that's why you have to use like route reflectors and things like that. Although I kind of like this, but maybe that's the AS path thing with that maybe is what causes iBGP to not do that. I don't remember, but we'll just go with those two. Could be wrong on that. Which eBGP feature must be used when peering to a non-directly connected peer address? So it's going to be something that is multiple hops away, which actually is going to be in the answer to what it is. So it's the multi-hop command. It's not multipath. It's not local preference. It's not AS path. Let's see. And by the way, if you actually want to dig in a little bit more to BGP and OSPF, I have a whole bunch of labs that I actually have. There's a playlist for them. I think I was putting them together kind of like as CCNP labs, but they're both open protocols and pretty much work almost the same way across most vendors. So definitely good to get your hands dirty with those for sure. Which statement is correct about OSPF? OSPF is a distance vector protocol, a device state protocol, definitely not that, path vector protocol, link state protocol. Pretty sure it's a link state protocol. Path vector, I think, is more like BGP, and distance vector, which is going to be dealing with like hops, is something like RIP. So we're going to link state. And that's why you kind of get like the different values and metrics get associated with the different interfaces as long as they're up. What's the first route selection mechanism for iBGP? I just know this off the top of my head, but AS path, med, origin, local preference. Local preference is something that you can use with iBGP, and is the first selection mechanism. Referring to the exhibit, which protocol is associated with the route selected for traffic destined to 10, 255, 14, 177? So we're looking at the output here. The route that is using the asterisk is what we want to see. We have all of these different routes here. We're looking for the 14.177, which is this one here. And we see that it is using the BGP route. So BGP, and then there's OSPF, right? So BGP is using a metric there of 8 is how that's being preferred over this OSPF of 10. So let's go BGP. Referring to the exhibit, which two statements are true? Choose two. So we're looking at, we're showing the BGP configuration. We got a group DC overlay, multi-hop, the local address that it's using, family EVPN. So they're using this to send the overlay traffic. and a neighbor IP address. But the configuration will pass a commit check. The BGP group is configured to attempt EGP peering with 192.168. Yes, we'll say it is. That is exactly what it's doing, but I don't think it will pass a commit check. And why will it not pass a commit check? It's missing something with the doesn't have the AS numbers anywhere in here. So it should have a neighbor with like the AS, so we would know, you know, what it's connecting to. So it will not pass a commit check. Which two statements describe an OSPF area border router? By default, an area border router is an OSPF router with links in two areas, right? So that's going to be a link to area 0 and then a link to something else. I like that. ABR is an OSPF router with all its links in one area. I don't like that. By default, ABR must have one link in the OSPF backbone, which I was saying was area 0. By default, ABR doesn't need to have a link now. So I think that's pretty straightforward. Again, go check out my OSPF lab videos, and we kind of cover the requirements that you need for the different types of, well, the whole architecture of OSPF, but then particular types of routers within the environment. I think we're good with that. Which statement is correct about OSPF link state database? And if you notice, link state, I think, was one of the answers for one of the other questions when we were talking about like distance vector and things like that. So always keep an eye out to see if there's like other things and questions that might help you out with previous questions. Some exams allow you to go back and forth. Sometimes they don't. So, but always good to try to pick up other information that you can go back and answer other questions that might help you with future ones. So link state database. Each router within the same area must maintain an identical copy of the link state database. I like that answer. So we'll click that. Each router with an OSPF domain must maintain a unique copy of the link state database. No, because I think within the same area, they have to have an identical copy. Each router within the same area must maintain a unique. No, it's going to be the same. And each router with an OSPF domain must maintain an identical copy of the link. And I don't think that's the case either, because within different areas, it could be different. So we're going to go with that first one. Referring to the exhibit, how many milliseconds will pass before the BGP neighbor is considered dead? Let's see. We are looking at minimum interval of 1000 milliseconds. And I think the default for BFD, I think it's 3 retries. So that should be 3000 milliseconds. So 1000 times 3. Referring to the exhibit, which statement is true? So we're showing a BFD session extension. So here we see the interval timer is 0.9. So almost 1000 milliseconds. And here we see the multiplier is 3, so we're talking about the default being 3. So what is the question? BFD only records a syslog message if 3 BFD packets are missed. I don't know about that statement. BFD will bring down a BGP session if no BFD packets are received within 2700 seconds. It's a long freaking time. Absolutely not. BFD will bring down the BGP session if no BFD packets are received within 2700 milliseconds. That would make sense because that's 3 times the 900 milliseconds. So I like that. That sounds pretty good. Which two statements are correct about aggregated Ethernet bundles? We're talking like LACP type of stuff. You must purchase a service license for the chassis to support aggregate Ethernet interfaces. Possibly, maybe. You must enable LACP when configuring aggregated Ethernet bundles. You must enable chassis supported aggregated Ethernet bundles. You must specify which interfaces are members of a specific. Okay, so have to specify the interfaces. I like that. You must enable chassis. I don't know. I think you need to turn it on as a feature and then specify the interfaces. I think I could be totally wrong on that though. I'm unsure on this one. I'm guessing. So we'll rock with it. We'll see what happens. We should be coming to the end here. I feel like I've been close to doing 40 questions. Which two statements are correct about using LACP on Juniper devices? Both sides of the LACP session must be in active mode to exchange LACP packets. That's not correct. You could have active on one side and passive on the other. LACP is used to automatically add and delete interfaces from aggregated Ethernet bundles on a Junos device. One side of the LACP session must be in active mode. I agree with that. LACP is used to monitor the status of aggregated Ethernet bundles members interfaces on a Junos device. I like that too. We'll see. Still unsure about the one right before that. With regards to graceful restart, which two statements are true? The network topology must be stable for graceful restart to work. I like that. Dual routing engines are required for graceful restart to work. Dual routing engines. Maybe. NSR must be enabled for graceful restart to work. I don't think so. Supported routing protocols such as BGP must be operational for graceful restart to work. I think that seems to be correct, right? So you need the protocol needs to be operational and up, and then the topology needs to be stable. It can't be in a state of flux. We'll go with those two. What is the advantage of using BFD? BFD is built to handle the routing table of the entire internet and can safely redistribute it into OSPF. That's a wild statement. BFD is so lightweight that each protocol will generate its own unique BFD session by default to replace its own hello messages. One BFD monitoring session can be used by multiple protocols. I like that. I think that could be it. BFD is built to handle the routing table of the entire internet. Stop it. Just stop it. BFD monitoring sessions can be used by multiple protocols. I like that one. We'll go with that one. Okay, that's the end. So let's see. We hit submit and see how many we got incorrect. Okay, hey, we crushed it. We did pretty good. Let's see which ones we got incorrect. Okay, so the cool thing with this, I'm not going to do this because we don't need to, but they do give you a little bit of breakdown about why the answers are the answers. I mean, we kind of did that, so especially on the ones that we got correct. I don't necessarily feel the need to do that, but go back. You take the test, you go through, you can read through these. We can just kind of move through these and see what we get. We talked about that. I did that. I wonder how many we got wrong. Maybe 2? Maybe 1? I don't know. We'll see. And I'm kind of instead of just clicking through here, I am kind of going a little bit slower so that if you're going through here and you actually do want to read it, then it gives you enough time to pause the video so that you can actually read what it says. Would be nice if they gave you, like, I guess because they mix up the questions, they can't kind of tell you how many numbers, like what number question you're on. And as I said, it's not going to be the same exact questions in the voucher test, but I found from doing this 6 other times, the level of difficulty of the questions is about the same. So if you can kind of go through this and crush this pretty good, not because you've gone through and done this multiple times, but because you kind of understand what the answers are and why they are that way, you should be able to go and take that voucher assessment test and do pretty well with it. Okay. Okay. I knew that it was using ASPath to avoid loops. Yeah, so that doesn't, like, the sessions can be established either from physical router interfaces or loopbacks. I think best practice normally is to do from loopbacks though. Just so if physical interfaces go down and there's other paths there, the session can still, you know, be established. Okay. Fair enough. Okay. Referring. So what did we get wrong here? The BGP group is configured to attempt eBGP peering session with 192.168.100. So these are the same answers. The issue is they probably meant to put a 1 instead of a 2 on one of these. I would say probably on this one. And so this one is marked correct. But if we did go, the answer is peering session with 192.168.100.2. So we're not going to count that one incorrect. It's probably the only 2 that should have been wrong. So we were right with the LACP question. Okay, good, because I was wondering what was going to happen with that. Must enable chassis support for it, and then you specify the interfaces. Cool. And then we got the LACP questions right. Yeah, BFD is not built to handle the entire routing table of the internet. Awesome. Awesome, awesome, awesome. So, as I said, that will wrap it up. I'll put links in the video description. If you're interested in this or any of the other Juniper stuff, go check out the playlist. I have tons of different stuff there. It's probably pretty helpful when it comes to looking at the Juniper Associate certs. So if no one has any other questions or anything like that, we pretty much can go ahead and wrap this up. As always, I appreciate you dropping in. If you're here all the way to the end and you haven't hit the like button, haven't subscribed, please go ahead and do that. Go get at it. Have a great week, and we'll talk soon. All right.